Our second concept will be the net ionic equation. And what is the net ionic equation? Net ionic equation. Net ionic equation, it includes only those compounds or ions that undergo a chemical change in a reaction in an aqueous solution. So, our net ionic equation, if I have A, B as a compound react with C, D, that is aqueous, and that's my aqueous compounds. And they produce A positive, B negative, C positive, D negative. So they produce AD plus CD. We must know that to write the net ionic, that's my chemical equation, that's my normal chemical equation which I used to write AD plus CD, it produced the AD plus CD. It is an example to double displacement reaction also. So, to identify these, we must know that if it is soluble, so we must write aqueous. If it is not soluble, we write S or L. S, it means a solid, precipitate. L, it means liquid. And we can write gas, if it is a gas. So SLG, solid, liquid, gas, or aqueous. These are my physical states of the results. But to write the net ionic equation, if I have AB, it is A positive aqueous plus B negative aqueous plus CD positive, C positive aqueous plus D negative aqueous. That's my original equation. It produced A, since AD, as I see, is AD is an aqueous, so I can write A positive aqueous plus D negative aqueous. Plus, if I have CB, my CB is a solid, as example. If I have CB is a solid, it is a precipitate, so I must write it CB like that. It is not aqueous, so it is not dissolved or it cannot dissociate. So A plus B plus C plus D with their charges produce A plus D plus CB compound. My ions which repeated, A is repeated, and also D is repeated in the reactants and products. So I will cancel them because they still aqueous, like that A aqueous, D aqueous, produce A aqueous plus D aqueous. If I want to get my net ionic equation, my net ionic equation from the previous, so I must write the ions which includes in the A produced as A, so it doesn't, it is not included. D produced as D negative aqueous, so it's still D negative. But B, C produced CB, so B aqueous positive plus, or negative, sorry, negative plus C aqueous positive produced CB solid. So that's my net ionic equation, or my final net ionic equation. And the ions which not included, like A, D, they are spectator ions. They are called spectator ions. So if I want to know the net ionic equation of a compound will react with another compound, I must write these compounds and the products also, and to know the ions which share in the reaction, I include them in the net ionic equation like B and C. And I must know the ions which not included in the reaction. So they are spectator ions, spectator ions, spectator ions, spectator ions. What are spectator ions? That's my second concept, is spectator ions. These ions which not included in the reaction, or I can say these ions which do not take part in the reaction. They do not take part in the reaction. These are spectator ions, as A and B in the previous example. If we want to understand what is meant by net ionic equation and spectator ions, we will go to the previous example. Our example of, to understand that, we must apply that in our previous example. We have ammonium sulfide and cadmium nitrate again. Ammonium sulfide plus ammonium sulfide and cadmium nitrate and cadmium nitrate in O3, cadmium nitrate O2. First of all, we must know that these substances must be aqueous, as we said before, to react with each other, and we know the products we want to make net ionic equation, we must use them as an aqueous, like that, an aqueous solution. And we know that the products are ammonium nitrate. We will take two common factors in front of the compound. Ammonium nitrate aqueous, because it dissolves ammonium group, make it soluble, and cadmium sulfide. Cadmium sulfide is a solid or precipitate. That's not my ionic equation, and if I want to change it to ionic equation, we did that before, and we will repeat it quickly to deduce also the spectator ions, or to know the spectator ions. So my ammonium sulfide, ammonium will be 2NH4, ammonium aqueous, positive, plus sulfide aqueous, -2, plus ammonium sulfide, and cadmium nitrate, cadmium +2 aqueous, plus nitrate, 2 nitrate, because I have cadmium nitrate, 2 groups of nitrate, -1. I must know the charge also. To produce our new ions, ammonium will be with nitrate as 2NH4, because they are still aqueous. Ammonium is still aqueous, so also in the product it is still ammonium positive aqueous, plus also nitrates are soluble, so it is still aqueous. But I have here cadmium sulfide already reacted and produced CDS, and I know all sulfides are insoluble except all sulfides, from my general rule, all sulfides are insoluble except some sulfides like that. So cadmium sulfide is a precipitate, or cadmium sulfide is solid. And so we have here our spectator ions, which not included ammonium. I have ammonium here, so it is a spectator ion. Also nitrate comes in the products, nitrate, but already so ammonium and nitrate are my spectator ions. Spectator ions are ammonium positive and nitrate negative. Why? Because they enter in the reactants as here and in the products. Also nitrate in the reactants and also in the products. But my net ionic equation is cadmium and sulfide ions, sulfide -2 aqueous plus cadmium +2 produce cadmium sulfide solid. That's my net ionic equation. Now we are going to practice in page 416. Practice. In page 416 in your book, page 416, we have when a precipitate form in a solution of potassium sulfate, number one, if I have potassium sulfate and barium nitrate, potassium sulfate SO4, must write it like that, and barium, potassium sulfate and barium nitrate, barium Ba, nitrate in O3O2. So I must use them aqueous. I must add them in aqueous, not in solids as we said before. How can I know if a precipitate will be formed or not? That's not practice problem 1 in page 116. So we must put them in an equation and know the net equation and the spectator ions, everything to understand how there will be a solid substance or solid product, and write the net ionic equation for that. So I can write that equation like potassium will take nitrate and I will take 2 common factor, positive will take negative and the potassium will take nitrate, and 2 is a common factor, a potassium nitrate aqueous, since all potassium are aqueous from the general rules. And barium will take sulfate, barium sulfate, it is a solid from your rules. So you most sulfates are soluble except barium strontium. That's my barium, so it is one of the exceptions. All sulfates are soluble except some exceptions like barium sulfates and strontium in your general rules, also in page 413 as we said before. So barium sulfate is a precipitate or a solid, as you see. So everything is clear now to write my ionic equation, then net ionic equation. So you can solve any problem in 3 steps, 1, 2, 3. You will write ionic equation. Then you will know the spectator ions. spectator ions. So the last thing is to write the net ionic equation. It is very easy to do these three steps. First, we will make ionic equation. How can I make an ionic equation? I will return to my equation, potassium sulfate K2SO4 aqueous, the first substance. We will take 2 potassium positive plus sulfate -2 aqueous plus barium +2 aqueous, and also 2 nitrates -1 aqueous. So that's my equation. And I can, what are my products? You must know that you produce the potassium nitrate, still aqueous in the products. Aqueous here in the products. So I can write potassium as it is. So I can write the ionic equation. We will write my ionic equation like that: potassium 2K as it is, potassium aqueous, and nitrate 2NO3 here -1 aqueous plus potassium nitrate, and barium will take sulfate. To produce barium sulfate, it will be solid. Barium sulfate solid. So how can I know that's my equation? These are my reactants, okay, and these are my products. My reactants: potassium aqueous, sulfate aqueous, barium +2 aqueous, and 2 nitrate aqueous. My products: potassium nitrate and barium sulfate solid. So my spectator ions, which not included, are ions which repeated. I can see that 2 potassium in the reactant and 2 potassium in the products. So it is my spectator ions. That's the second part of my ionic equation. That's potassium is a spectator ion because it is repeating. Also, what are the other one repeated? Nitrate. You know that nitrate is repeating. So it is not included in the reaction. But you can see that barium and sulfate produce barium sulfate is a solid substance, which is precipitate. So my net ionic equation will be like that: barium +2 aqueous plus sulfate -2 aqueous, it produces barium sulfate BaSO4. It is a solid. So barium plus sulfate is produce barium sulfate, and it is a precipitation reaction. Since barium sulfate is a solid, so it is a precipitation reaction. That's my net ionic equation in this example. Also, the second example, also the same idea. We can write that easily. We will go to ionization, another concept to call ionization. Ionization. What is ionization? Ionization, ions are formed from solute molecules by the action of the solvent. Yes. If I have solute by the action of a solvent, if that solutes contain ions like AB and produce A aqueous plus B negative aqueous, so that is ionization. When we add the solute in the solvent, the action of the solvent on the solute dissociate it or separate it into its ions, A positive and A negative. We will take an example on that. Example. If I have something called HCl, it's called hydrogen chloride. You must know that HCl is hydrogen what? Chloride. I know that all of you, mashallah, smart enough, but some of you say that HCl is hydrochloric acid. No. First, it is hydrogen chloride gas. But when we dissolve it in a solvent like water, as an example for a solvent, it will be HCl aqueous, which is called hydrochloric acid now. You can call it hydrochloric acid. So I cannot call all HCl as hydrochloric acid. It is wrong concept. Most of you say HCl is hydrochloric. No. If HCl is a gas, it is hydrogen chloride gas. But when it dissolves in water, it produces HCl aqueous. That's your hydrochloric acid now. And when you get that concentrated hydrochloric acid and you dissolve it in water also, it will dissociate. It will ionize. Dissociate, then ionize. How can it ionize? It will produce H positive and Cl negative. As you see, HCl aqueous, hydrochloric acid now, and in water, in H2O, it will produce H positive aqueous and Cl negative aqueous. So we can apply the ionization concept on HCl. It dissolves in water in H positive aqueous and Cl negative aqueous. It contains a highly polar compound, and the HCl molecule is strong enough to break the water as a polar molecule is strong enough to break the bond, because water is a polar compound. It can dissociate HCl into H positive and Cl negative, and dissociation increases when we add more water, form hydrogen ions and the chloride ions. We must know a new concept. It is related to formation of ions. It is called hydronium ions. Hydronium ions. Hydronium ion. Hydronium ion, it is called H3O positive. For any acid can dissolve in water, like the previous example, hydrochloric acid, HCl. When HCl dissociate as a gas in water, in H2O liquid, it can produce that hydronium ion. It will form first hydrochloric acid. That hydrochloric acid dissociate in more water, and the H will with water go to water molecule and they produce H3O positive aqueous and Cl negative aqueous. So that's hydronium ion. It is the connection between the hydrogen of the acid and the water molecule which the acid will dissolve in it. Our last concepts are the electrolytes and their classification. What are electrolytes? Electrolyte, and I have three types: strong, weak, and non. Strong electrolyte, weak electrolyte, and non-electrolyte. I must know that what is meant by electrolyte first. First, electrolyte is any substance can dissolve in water or a solvent and produce and produce ions. Electrolyte is any substance can dissolve in water and produce ions. So it can conduct electricity or electric current. That is electrolyte, electricity. So electrolyte is any substance that dissolve or dissociate in water and produce ions. It's very important. Ions, these ions can conduct electricity. So that's electrolyte. I have three types: strong electrolytes, and weak electrolytes. Number three, non-electrolytes. How can I distinguish between them? Between strong, weak, and non? Strong electrolyte, it means the substance that completely dissociate or separate, like HCl, as an example, is hydrochloric acid is a strong electrolyte. And sodium chloride is a strong electrolyte. In HCl, iron is a strong aqueous, also a strong electrolyte, because they are completely separate into positive and negative, ions. That's the strong electrolytes. But the weak electrolytes, like HF, hydrogen fluoride. You must know that, hydrogen fluoride. And CH3COOH, it is called acetic acid. Or hydrogen. The weak electrolyte is any compound or dilute aqueous solution conducting electricity. Like that, it is weak. It is partially ionized, not completely ionized. But HCl and NaCl are completely ionized. Non-electrolyte is not conducted like sugar because it is not ionic compound. So I have three types: strong electrolyte, weak electrolyte, and non-electrolyte solutions.